A media access control address is a unique identifier assigned to network interfaces for communications on the physical network segment. MAC addresses are used as a network address for most IEEE 802 network technologies, including Ethernet. Logically, MAC addresses are used in the Media Access Control Protocol sublayer of the OSI reference model. MAC addresses are most often assigned by the manufacturer of a network interface controller and are stored in its hardware, such as the card's read-only memory or some other firmware mechanism. If assigned by the manufacturer, a MAC address usually encodes the manufacturer's registered identification number and may be referred to as the burned-in address. It may also be known as an Ethernet hardware address or physical address. This can be contrasted to a programmed address, where the host device issues commands to the NIC to use an arbitrary address. A network node may have multiple NICs and each NIC must have a unique MAC address. MAC addresses are formed according to the rules of one of three numbering namespaces managed by the Institute of Electrical and Electronics Engineers, MAC 48, EUI 48, and EUI 64. The IEEE claims trademarks on the names EUI 48 and EUI 64, in which EUI is an abbreviation for Extended Unique Identifier. Notational conventions: the standard format for printing MAC 48 addresses in human-friendly form is 6 groups of 2 hexadecimal digits, separated by hyphens or colons, in transmission order. This form is also commonly used for EUI 64. Another convention used by networking equipment uses 3 groups of 4 hexadecimal digits separated by dots, again in transmission order. Address details. The original IEEE 802 MAC address comes from the original Xerox Ethernet addressing scheme. This 48-bit address base contains potentially 248 or 241,474,976,710,656 possible MAC addresses. All 3 numbering systems use the same format and differ only in the length of the identifier. Addresses can either be universally administered addresses or locally administered addresses. A universally administered address is uniquely assigned to a device by its manufacturer. The first 3 octets identify the organization that issued the identifier and are known as the organizationally unique identifier. The following 3 or 5 octets are assigned by that organization in nearly any manner they please, subject to the constraint of uniqueness. The IEEE has a target lifetime of 100 years for applications using MAC 48 space, but encourages adoption of EUI 64s instead. A locally administered address is assigned to a device by a network administrator, overriding the burned-in address. Locally administered addresses do not contain OUIs. Universally administered and locally administered addresses are distinguished by setting the second least significant bit of the most significant byte of the address. This bit is also referred to as the UL bit, short for Universal Local, which identifies how the address is administered. If the bit is 0, the address is universally administered. If it is 1, the address is locally administered. In the example address 06-00-00-00-00-00, the most significant byte is 06, the binary form of which is 00000110, where the second least significant bit is 1. Therefore, it is a locally administered address. Consequently, this bit is 0 in all OUIs. If the least significant bit of the most significant octet of an address is set to 0, the frame is meant to reach only one receiving NIC. This type of transmission is called unicast. A unicast frame is transmitted to all nodes within the collision domain, which typically ends at the nearest network switch or router. A switch will forward a unicast frame through all of its ports if the switch has no knowledge of which port leads to that MAC address, or just to the proper port if it does have knowledge. Only the node with the matching hardware MAC address will accept the frame. Network frames with non-matching MAC addresses are ignored, unless the device is in promiscuous mode. If the least significant bit of the most significant address octet is set to 1, the frame will still be sent only once. However, NICs will choose to accept it based on criteria other than the matching of a MAC address, for example, based on a configurable list of accepted multicast MAC addresses. This is called multicast addressing. The following technologies use the MAC48 identifier format: Ethernet, 802.11 wireless networks, Bluetooth, IEEE 802.5 token ring, most other IEEE 802 networks, fiber distributed data interface, asynchronous transfer mode, switched virtual connections only, as part of an NSAP address, fiber channel and serial attached SCSI, the ITU-TGHN standard, which provides a way to create a high-speed local area network using existing home wiring. The GHN application protocol convergence layer accepts Ethernet frames that use the MAC48 format and encapsulates them into GHN medium access control service data units. Every device that connects to an IEEE 802 network has a MAC48 address. Common consumer devices to use MAC48 include every PC, smartphone or tablet computer. The distinction between EUI48 and MAC48 identifiers is purely nominal. MAC48 is used for network hardware. EUI48 is used to identify other devices and software. The IEEE now considers the label MAC48 to be an obsolete term, previously used to refer to a specific type of EUI48 identifier used to address hardware interfaces within existing 802-based networking applications, and thus not to be used in the future. Instead, the proprietary term EUI48 should be used for this purpose. The EUI48 is expected to have its address base exhausted by the year 2100. EUI64 identifiers are used in FireWire, IPv6, Zigbee/802.15.4/6 Low WPAN wireless personal area networks. The IEEE has built in several special address types to allow more than one network interface card to be addressed at one time. Packets sent to the broadcast address, all 1 bits, are received by all stations on a local area network. In hexadecimal, the broadcast address would be FF, FFFFFFFFFF. A broadcast frame is flooded and is forwarded to and accepted by all other nodes. Packets sent to a multicast address are received by all stations on a LAN that have been configured to receive packets sent to that address. Functional addresses identify one or more token ring NICs that provide a particular service, defined in IEEE 802.5. These are all examples of group addresses, as opposed to individual addresses. The least significant bit of the first octet of a MAC address distinguishes individual addresses from group addresses. That bit is set to 0 in individual addresses and set to 1 in group addresses. Group addresses, like individual addresses, can be universally administered or locally administered. In addition, the EUI64 numbering system encompasses both MAC48 and EUI48 identifiers by a simple translation mechanism. To convert a MAC48 into an EUI64, copy the OUI, append the 2 octets FFFF and then copy the organization-specified extension identifier. To convert an EUI48 into an EUI64, the same process is used, but the sequence inserted is FFA. In both cases, the process can be trivially reversed when necessary. Organizations issuing EUI64s are cautioned against issuing identifiers that could be confused with these forms. The IEEE policy is to discourage new uses of 48-bit identifiers in favor of the EUI64 system. IPv6 one of the most prominent standards that uses a modified EUI64 treats MAC48 as EUI48 instead and toggles the UL bit. This results in extending MAC addresses to modified EUI64 using only FFFE and with the UL bit inverted. Individual address block. An individual address block is a 24-bit OUI managed by the IEEE Registration Authority, followed by 12 IEEE-provided bits, and 12 bits for the owner to assign to individual devices. An IAB is ideal for organizations requiring fewer than 4097 unique 48-bit numbers. Usage in hosts. Although intended to be a permanent and globally unique identification, it is possible to change the MAC address on most modern hardware. Changing MAC addresses is necessary in network virtualization. It can also be used in the process of exploiting security vulnerabilities. This is called MAC spoofing. A host cannot determine from the MAC address of another host whether that host is on the same link as the sending host, or on a network segment bridged to that network segment. In IP networks, the MAC address of an interface can be queried given the IP address using the Address Resolution Protocol for Internet Protocol version 4 or the Neighbor Discovery Protocol for IPv6. In this way, ARP or NDP is used to translate IP addresses into Ethernet MAC addresses. On broadcast networks, such as Ethernet, the MAC address uniquely identifies each node on that segment and allows frames to be marked for specific hosts. It thus forms the basis of most of the link layer networking upon which upper layer protocols rely to produce complex, functioning networks. Usage in switches. Layer 2 switches use MAC addresses to restrict packet transmission to the intended recipient. However, the effect is not immediate. Bit reverse notation, the standard notation, also called canonical format, for MAC addresses is written in transmission bit order with the least significant bit transmitted first, as seen in the output of the uproot2upconfig command, for example. However, since IEEE 802.3 and IEEE 802.4 send the bytes over the wire, left to right, with least significant bit in each byte first, while IEEE 802.5 and IEEE 802.6 send the bytes over the wire with the most significant bit first, confusion may arise when an address in the latter scenario is represented with bits reversed from the canonical representation. For example, an address in canonical form 12-34-56-78-9 ABC would be transmitted over the wire as bits 010010101010101010101010101010101010101010101010101010101010 in the standard transmission order. But for token ring networks, it would be transmitted as bits 0001000100010001000100010001000100010001000100010001000100010001000100010001000100010001000100010001000100010001000100010001000100010001000 in most significant bit first order. The latter might be incorrectly displayed as 48-2C6A1E-59-3D. This is referred to as bit reversed order, non-canonical form, MSB format, IBM format, or token ring format, as explained in RFC 2469. Canonical form is generally preferred, and used by all modern implementations. When the first switches supporting both token ring and Ethernet came out, some did not distinguish between canonical form and non-canonical form and so did not reverse MAC address bits as required. This led to cases of duplicate MAC addresses in the field. See also, Organizationally Unique Identifier, Internet Protocol version 6, Hot Standby Router Protocol or Standard Alternative VRRP Virtual Router Redundancy Protocol, which allows multiple routers to share one IP address and MAC address to provide router redundancy. The OpenBSD project has an open-source alternative, the Common Address Redundancy Protocol. On Linux, Iptables is a cluster IP target. NSAP address, another endpoint addressing scheme. Sleep proxy service, which may take over another device's MAC address during certain periods, references. External links, IEEE Registration Authority Tutorials, IEEE Public OUI and Company Ad Assignment Lookup, IEEE Public IAB List, IEEE Searchable List Lookup OUI Database, IEEE Public OUI List, IANA Considerations and IETF Protocol Usage for IEEE 802 Parameters, IANA List of Ethernet Numbers, IRIS HICS OUI Lookup Tool and MAC Address List, MAC Address Lookup Tool.